Alright, let's look at this problem. How do you find the volume of the solid with base region bounded by the curve y equals e to the x, so exponential curve, and y equals natural log of 4, this is just a horizontal line, and the vertical line x-axis. If cross-section perpendicular to the y-axis are squares, right? So first, let's look at the base region. Right, so I'm gonna just draw x-axis, right, and also y-axis, and here's the origin. Right, so the graph is gonna look like so it's an exponential function, so we know how to draw exponential function, and it's increasing. It's actually increased quite rapidly, and it's gonna go through y-intercept is going to be 1 because e to the 0 is 1, so that's going to be 1 there, right? And y equals natural log of 4, so that's going to be just a horizontal line at the natural log of 4, so this is going to be a natural log of 4, so this is y equals natural log of 4. Right, so here, natural log of 4, right there. Right, this guy is y equals e to the x, right? And the y-axis is right there. So you can see that the region we're talking about is this region right here. Right. So this is the base region, right? Then we're gonna have a cross section, which is cross section that are squares. So we're gonna use so each one, for example, if you pick this y, so the side of the base, I mean the square, one side of the square is determined by this guy right here, right? So because it's kind of hard to draw, so you're gonna have a square above it like that. I don't know, you can see that. Alright, to make it a little bit clearer, I'm gonna try to do a three-dimensional picture. Alright, so let's say here's the x-axis, and here's the y-axis, right? And I'm going to just put the z-axis just to make it look more of a three-dimensional. Oops, that's not exactly where I want it. So here, yeah, that's good enough. Right, so here's z. Right, let's sketch this region. So y-axis is there, right? So exponential function. So it's gonna look, let's see, something like this. All right, and y equals natural log of 4 is probably looking something like this. It has to be parallel to the x-axis, right? And the region we are talking about, so you just kind of lay this down here, so on the bottom, so we have that. Right, so what happens is for each cross section perpendicular to y, so you are taking a cross section, think of it as you're slicing the object by a plane perpendicular to y. So let's see, let's draw this. It's kind of hard to visualize this, so think of this as a plane going like this, right? Then the cross section with this plane perpendicular to y is going to look somewhat like this. So it's going to be a square. So you have, let's see, that. Alright, maybe it's going to look more like this. Alright, So this is the cross section, right, which is a square, right? And in order to visualize the whole solid, you're gonna have a whole bunch of squares, right? And this is gonna be a small square here, and even smaller square here, and here you're gonna have fairly large square there. So let's see if I can draw this, right? So if you combine all of those guys together, you're gonna have a solid looking somewhat like that, right? So maybe I'll maybe color this guy. So this is the solid we're looking at. Not the greatest picture, but hopefully you can kind of see that, right? So we want to find the volume of that solid, right? So remember that, so if you can find the cross-sectional area, so for example, take this guy, so here, right? And at y, right? So right, so one side of the square can be determined. Looks like this is going to be a distance, horizontal distance or x direction distance from the y-axis to this exponential curve, right? So we're looking at the x value from this equation right here. So unfortunately, this is written in the form of y equals e to the x, but we want to find the x value in terms of y, so we just have to rewrite it. So we can just take the natural log of both sides, then you have a natural log of y is equal to and natural log of e to the x, right? Remember that the natural log and the exponential functions are inverses of each other, so they, in a way, they cancel out each other, so you just get x, right? So x is equal to natural log of y, right? Which means that the length of one side of the square here, let's not use the same color. Let's see, I'm going to use a red. So here, this length right here can be expressed as x equals natural log of y. All right. So since the cross-sectional area, cross-section is a square, so it's going to be natural log of y times the natural log of y give you the cross-sectional area. So cross-sectional area A, and in terms of y, can be expressed as natural log of y squared. All right. Then remember that if you want to find the volume and knowing the cross area of the cross sections, then all you have to do is we have to integrate then cross sectional area. So in this case, in terms of y, so a of y, then with respect to y, so dy, right? Then you have to go from some y value to another y value. All right, let's put the actual function in. So here we have, let's see, so the volume that we are looking for, v, is going to be integral, right? Then the area function here is just natural log of y squared with respect to y, right? Then we have to start. We have to think of, find where these squares starts and where they end. So it looks like it's going to start from here, which is the y-intercept of this exponential function, which is 1, right? So it's going to start from 1, and then y value increases all the way up to y equals natural log of 4. So which means that integral, it's going to start from 1, because y is going to start from 1, and all the way to y equals natural log of 4. So it's a natural log of 4. Right? So this is how we set up the integral for the volume of the solid that we're looking for. Alright, so I will do a separate video to actually evaluate this integral, and we probably have to use integration by parts twice to get to the value. Alright, so that's it. I hope that this was clear.